Test. Hello. Hello. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today, we will like to explain about Fourier transform in acoustic field. Next slide. This is our group members. Contain Aiman Aziz, Ahmad Khalil, Rabbani, Aiman Syakir, Nur Firas, and Firdaus Zulkifli. First and foremost, who was Fourier? Jean-Baptiste Joseph Fourier became obsessed with heat transfer and devised an equation to describe heat conduction in solid bodies. He devised the Fourier transform to solve this equation in under 7 years. From solving linear differential equation to building computer models to data processing and analysis, Fourier analysis is used in almost every aspect of the subject. So we can close. Next slide. What is Fourier transform? Firstly, Fourier transform is a mathematical tool used to represent any signal for frequency analysis of signal. Fourier transform is also known as frequency domain, represent the original signal. The Fourier transform can exist for every signal, power signal, and impulse-related signal. These signals are integrable signal that will have Fourier transform and use properties. Secondly, Fourier transform must have finite number of maximum and minimum, which are the highest and lowest value of the signal or the proper signal. The finite number of discontinuities in the signal required to form Fourier transform representation. This can represent to transform time domain to frequency domain. So I will pass the next slide to.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lutfi Rabi Rahman. Thank you for Mazik for explaining what is Fourier transform. Before we proceed to the condition for Fourier transform, there's few things that we know that before we need to use the formula or to use the theory, we need to understand the condition, which is firstly, the signal should be absolutely integrable. Next, the function must have finite number of maximum and minimum value. And last but not least, the function must have infinite number of discontinue in the signal. All the circumstances must be in the proper condition in order for us to use it, the Fourier transform. Okay, next slide. These are the formula that can be used in the Fourier transform, which is f equal to integration of infinite f time exponent and power of I, and the integrate must be in time, which is we need to integrate it. And the inverse Fourier transform of function is defined by ft equal to 1 over 2 pi. This is integrate by infinite number, and the integration must be in the delta, which is the Fourier transform signal. Okay. Next, I will pass to Daus.
Okay, thank you, Firas. Assalamualaikum. My name is Firdaus. Now I will present about the application of electrical engineering. Okay, in electrical engineering, where one deals with signal waveform and signal manipulation, any operation such as addition, multiplication, diffraction, or integration can be used to manipulate the data. The primary goal of Fourier analysis was to represent and analysis periodic occurrence using Fourier series by using Ohm's law in Fourier transformation. V mega equal Z mega I mega, where V mega and I mega are the voltage current Fourier transform. Next slide. The Fourier transform method is applicable and have been used in many fields of science and technology, such as application to IBVP, signal processing LTI system, cell phones, and image processing. Next slide. The application to IBV. The IBV solution, which comprises of partial and differential equation as well as boundary and beginner condition, may be for solved using the Fourier transform technique. The cell phones, the Fourier transform technique is employed in signal processing, such as sound produced by a musical instrument. The signal processing LTI system, any waveform can be considered a signal function of time. This might be anything in the actual world, such as an electromagnetic wave, the voltage across a resistance Vs time. The variant in air or pressure caused by your voice. The image processing. The Fourier transform is is in a variety of applications, including image analysis, filtering, reconstruction, and compression. Okay, that's all for me. Next presenter.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Makoliza. I will explain about the example for the question using Fourier transform method. Here is application of Fourier transform and calculation example of it in electrical engineering. So using the Fourier transform method, find I naught in time t in figure 18.20 when I supply is equal to 10 sine 2t ampere. Okay, for the next slide. Okay, for the first step, we need to convert all elements to frequency domain. So as you know, 2 ohm and 4 ohm, we convert to frequency domain. We got a 2 ohm and 4 ohm. For the value of the capacitor 0.5, we convert to the frequency domain, and we got 2 over j omega. And after that, we convert the I naught is equal to I omega. So the second step, we convert the supply what we call I supply to I omega. So we got j pi 10 in bracket delta omega plus 2 minus delta omega minus 2. Okay, that's it. The I supply when we convert to the I omega. And then to the third step, we apply circuit analysis to find I naught omega. And I naught omega, we can find it using a current divider rule. So the circuit for the circuit analysis in the omega is just the same in the question. We just change it to the value in I omega, such as I omega, and then the capacitor we got 2 over j omega. Okay, for the I omega, we use current divider rule. So 2 over 2 plus 4 plus 2 over j omega, we multiply with I omega. And then the I omega, we move it to the left, and we got I naught omega over I omega is equal to 2 plus over 2 plus 4 plus 2 over j omega. And then as we know, the transition equation is output over input. And for this equation, the output is I naught omega, and the input is I omega. And then we got, when we simplify the equation, 2 over 2 plus 4 plus 2 over j omega, we got j omega over 1 plus 3 j omega. And then we construct the equation of transition equation. We got I omega is equal to transition multiplied by I omega. And then the I naught omega, we got 10 pi omega multiplied by delta omega minus 2 minus omega plus 2, and over the 1 plus J the omega 3. And next slide is when we get the equation, we need to transform the equation to get I naught in time. So we got the equation I naught t is equal to 10 pi over 2 pi multiplied by 2 over 1 plus 6j multiplied by exponent j2 t minus negative 2 over 1 negative j6 exponent negative 2t negative j. Okay, and then for the answer we got like that lah. Right, that's all from me.
Okay, thank you Khalil for the explanation. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Rabbani and I will explain about application of Fourier transforms in acoustic. First of all, what is acoustic? Acoustic is a discipline of physics that studied in mechanical wave in gases, liquids, and solid, including the vibration, sound, ultrasound, and infrared wave. An acoustician is a scientist who works in the science of acoustic, whereas an acoustical engineer works in the field of acoustic technology. And acoustic is used in practically every area of modern civilization, with the audio and noise control sector being the most prominent. Okay, next slide. The Fourier analysis was used to find naturally occurring harmonics, to model sound and to define sound by breaking it up into pieces. For example, of the Fourier series and Fourier transform can be seen in relation to the music. Fourier analysis is the process of breaking down a musical instrument, sound, or any other periodic function into its constituent sine or cosine wave. The amplitudes of the constituent sine wave that make up the sound wave can be used to characterize it. The harmonic content of a sound is represented by the set of number, which is also known as the sound harmonic spectrum. The harmonic content of prologue musical note is the most essential determinant of its quality or timbre. Okay, next. So the figure show that harmonic content determine the waveform of the sound signal when displayed as a function of time. As you can see, switching from a time to a frequency plot can make the harmonic content more evident. So the amplitudes of the individual harmonics can be determined by Fourier analysis and displayed as a function of frequency. Next. You also can synthesize a sound from a sequence of pure tone generators by properly tweaking their amplitudes and phases and combining them together once you know the harmonic content of a sustained musical sound using Fourier analysis. So the process is known as Fourier synthesis. One of the main points from the Fourier analysis for sound reproduction is that percussive sound with quick transient require a high quality audio reproduction system. So why Fourier transform is used in audio? The fast Fourier transform FFT is an important measurement method in the science of audio and acoustic measurement. It convert a signal into individual spectral component and thereby provides frequency information about the signal. Next. So this is an example of equation on acoustic wave calculation. Fourier transform is then sum of two new Fourier transform. As you can see the formula where R is a sample number. We have two new Fourier transform in equation 3, so we can define real variable. Then at the last equation 7 is included in the most digital signal processing software we use FFT. Okay, next I will pass to Aiman Shaki. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Bernie. So I will continue on the application of Fourier transform acoustic. So the next application is audio production. The equalization or EQ is an essential part of our audio production. The volume or specified frequency ranges can a basic use of equalizer is removing background noise from an audio file. As you can see on the image below, top panel shows an audio signal and bottom panel shows the equalizer itself, which increases or decreases the gain of the frequency ranges. The next application is the EEG or electroencephalogram. EEG is a technique for recording electrical activity from our brain. Spectral analysis of EEG is widely used, that is the examination of a signal by constituent frequency energies. A widely used convention of frequency bands in EEG is given below. As you can see, a delta band, a theta band, alpha band, and beta band. Okay, is all that is a common frequency band that we use in EEG. So for discussion, in the world that we live in, engineers in the field of communication system are anxious about dealing with signals and propagation waves. This is where Fourier transform that takes place to overcome these problems by breaking them into smaller parts that can help engineers to understand the main concept behind the theorem. Throughout these findings that have been done, we have looked at and observed different waveforms and learned about how Fourier transform can be adapted to each application and how it helps to improve each field. And for the conclusion, by using Fourier transformations, we can use the knowledge in order to deal with the signal and propagation waves. A lot of harmonics in Fourier transform were needed for the interpretation of the square wave, as it has infinite slope that is not characteristic. The triangle wave is the opposite, as it has a constant slope like a cosine wave. Having done these findings has allowed us to acquire a good understanding of the concept of Fourier transform, and this is how engineers gain knowledge and apply knowledge in the real world. So that's all from us. Thank you, Madam, for listening. And Assalamualaikum warahmatullahi wabarakatuh.